session of your requirements management. My name is Fernando Valera. I'll be conducting this webinar. The webinar will consist of now a presentation. At the end of the presentation, we will have a Q&A session where you will be able to post all your questions. You will be muted throughout the webinar, but you can post your questions at the panel at the right-hand side. So feel free to post your questions at any point during the webinar. Again, you will be muted throughout the webinar, that we will leave 15 minutes for Q&A at the end of the session. The agenda for today's webinar is what is Visur requirements, what are the advantages, what is it, what is the iTunization of requirements, or putting it another way, what is the difference between the document-oriented approach and an information-centric approach when dealing with requirements. We will then go and see what advantages this approach brings to the table, and then we will take a look at a Visur requirements demo. So what is it that makes Visur, our requirements management solution, unique? The first aspect is the fact that Visur is a process-oriented tool. What we try to provide is a tool that can help users follow the process instead of being a burden. For that, what we are providing is a graphical representation of the different element types, of the traceability, representing the data model, what we should be doing, how we should be doing it, so that users can actually follow that flow of information in the most appropriate way. Not only that, but apart from representing graphically all those elements, we will be able to check a button and enforce this data model that we are proposing. We will see afterwards this data model during the demo and how we managed it and how we were able to customize it to our own process. The second aspect is the collaboration. We try to provide a collaborative environment. What does that mean? Collaboration, from our point of view, is providing the right information to the right user at the right time. So Visur is a tool that provides a different set of roles, absolutely customizable. So when you get into the product, you're not just accessing it as a John or James, but as a product manager. What does that mean? Well, it means that for the sake of being a product manager, you will be presented with information in a specific way, opposed to, for instance, developers that might want to see the same information in a completely different way. We will be able to see information in a word-like view, for instance, when typing in requirements. We will be able to see them in an Excel-like view. We will be able to see information in a diagram, or even in a traceability tree. Apart from that, we also provide workflows, attribute workflows that can help us perform review and approval processes based on the role. So not only can not everybody can approve a requirement, so we can define the different steps towards an approval or a review, and we can identify the roles that can actually transition each one of the steps. And the final aspect is the quality. We try to escape from a pure management approach where the output is never better than the input. What we try to do is receive information, improve the quality, to basically improve the overall quality of the final system. To be able to do this, we first of all provide what we call the quality analyzer. This quality analyzer routes requirements and highlights problems in the description straight from the beginning, so that we can guarantee that errors are not propagated to later phases in the life cycle. So things like ambiguous terms, inconsistent terms, escape clauses like etc., for example, and so on. Things like that should actually be avoided in a requirement description. Or for instance, terms like should, or all those things will be highlighted while writing the requirements to be able to make sure that we get them straight from the beginning. Apart from that, we will also be able to compare different specifications to find inconsistent terms that are overlapping and meaning the same, or elements that are contradicting between two specifications. So if we are able to get to a high level, high quality set of requirements that we can include in a package and create a component out of them, another capability that Visur provides is the possibility to reuse those assets throughout the project. We will take a very quick look at it and how that works, so that we can share quality to other projects. So reusability doesn't make sense if it's not paired along with quality. So how do we support all these three processes? Well, initially, requirements or throughout history, requirements have been managed exactly the same as we have been managing music in our computers. And I'm pretty sure we've all done the same thing, creating a music folder, inside of the music folder, creating the genres or the decades even, inside of each one of the genres, creating the artist, and then inside of the artist, the different albums. The problem with this approach is that, first of all, the folders are containers. So we can only place elements in one of the folders and all of its parents. But some of the MP3s or some of the albums actually belong to several of those folders. And it was pretty straightforward when we had this album from a specific artist that changes completely from the previous ones, and now it is a completely different genre. Instead of being a pop, it was a rock, or even worse, we didn't even know whether it was pop or rock, and we went and created a third folder called Pop and Rock. But then we found out that, hey, actually this other album I included here in pop should actually be in this Pop and Rock folder. So the problem is that when you create this folder structure, you are already enforcing a way of working and a way of classifying elements, even without noticing. So if we would like to change the way we are working, we would just have to redo the whole thing. It's just a tedious task, which in most cases we decided not to go through. So even when we decided to do a playlist, we had to browse the different folders, select each one of the songs, and then create a playlist or drag and drop them into Windows Media Player. So what is the evolution of this? The evolution is going from an information-oriented approach, and this is what we call the iTunization of requirements. So this is, by the way, the trend in which all the companies, all the applications are going through, where there's no folder constraint, there are no containers, but actually information is managed through tags. So in iTunes, you will have noticed that a song is not contained in a folder, but it's actually tagged as being pop, and you can also tag it as being rock at the same time. So if you would like to search for all the blues from the 70s, you just have to type it in or classify elements by decade, and you will go straight to those files. So searching and working with information in an information-oriented approach is much more effective than dealing with the folders. So why has the folder approach been so successful for so many years? Well, because it enforces a structured way of dealing with information. The problem is that nowadays we have exponential complexity in requirements. We no longer have to deal with thousands of the requirements. We have to deal with hundreds of thousands. And also, we not only have one project, but we also have reusability between projects. We even have different variants of the same project. So the complexity takes us to deal with the requirements in a completely different way. So the difference between the music and the requirements is the fact that we have to deal with traceability. So how do we deal with it? Visur provides graphical ways to represent the different element types in what we call the data model. In this diagram, the different element types are represented through boxes, which are to some extent the representation of the tags or the folders in the document-oriented approach. And the lines between them make explicit that there's an association between, in this example, the user requirements and the system requirements, between the system requirements and the component requirements, and between all three of them with a corresponding task. Going to this type of approach, we can represent things like generalization, indicating that component requirements are actually composed of mechanical, electrical, or software requirements. The good thing about this diagram is that we can tailor it to our own model. We can create new types, we can delete, we can customize it completely to what we need, and the traceability we need. We can extend it to represent software design. We can extend it to represent tasks, use cases, risks, or any other aspect we might need in our project. Not only that, but we can also use it to represent things like the system decomposition. This is just an example of a car, but we can have system requirements that we allocate to the different subsystems like the engine, interior control, chassis, but then we can allocate those into subsystems. And we will actually have the representation we had previously, dividing component requirements into hardware, software, mechanical, and also this allocation. So being able to have a multi-dimensional approach to the requirements will allow us to deal more efficiently with those requirements. Apart from that, this diagram represents the structure of the project. And therefore, we will be able to use them to integrate with third-party tools. So we will be able to take any of the logs in here, any of the types, and synchronize them with third-party tools to bring the output. So we can actually indicate that tasks will be synchronized with TFS or with Jira. The component tasks, system tasks will be synchronized with HP. So the elements that we will be able to see when we open that box are elements that are being managed with from a third-party tool that we're synchronizing real time. And the same applies to the traceability. So whenever we establish a traceability inside Visur, that traceability is taken to the other tool. And if we create a traceability in the other tool, that will actually come into our project. I would like to take the opportunity to remind you that you will be muted throughout the webinar, but you can post any question you might have in the panel on the right-hand side. We will leave some minutes at the end of the presentation for Q&A. So please, if you have any questions at any moment, just put them, write them in there. So one of the advantages of this information-oriented approach is the fact that elements are not only located in a specific folder, but we can reuse them and tag them and include them in any project we need. One of the capabilities is, that we provide is the reusability and the product line management, meaning that we can create reusable components like a mission computer. Let's imagine that we have this software component in here. We just send it out to a project, a system A. This project receives those requirements, and they will be able to create a variant out of them. They will be able to modify them. These modified requirements come out of mission computer, so we are creating a variant called mission computer A. We'll be able to do the same with the system B, or calling them mission computer B. At this point, we will have 3 elements with the same ID, but in different versions. The original version, the A version, and the B version. And exactly the same with the system C having mission computers. The interesting thing about this is that we can actually create a second version of the original component, solving bugs, adding features, or extending the capabilities of that mission computer. And then we can share it to the different projects that are reusing that component. So they will be able to receive them and merge them to the version, creating mission computer A prime, mission computer C prime, and some of them might skip this hub. So what an information-centric approach provides, and what I've introduced in the slide, is the fact that this information-centric approach is a more efficient way to access the information. We don't need to browse, but we just need to search for information. Browsing, when it's a small project, might be okay, but when we're dealing with a high amount of information, we not always know where the elements are located or even allocated. We need to be able to search information. It's more controlled because we keep track of the elements at individual level instead of at document level. But yet it's more dynamic because we will be able to trace the element, the corresponding elements, to the right task cases, to the right subcomponents, components, and also another very important aspect is the fact that it's more, we can adapt to changes. So if we have a change in the process, we don't need to rearrange the folders. We just need to rearrange the diagram. And finally, this approach provides a better environment to reuse requirements and create product value. So let's move on to the tool and let's see this working. So I'll open Visur requirements and I'll open an example project where we work with a surgical imaging project. And the first thing we see is that we not necessarily have a document where we display the requirements. We just have whatever view with the corresponding information in here that we can search. Let's say that we want to find out all the elements that are rejected. So we just need to type it in here, and we will find all the requirements in the project belonging to different specifications, like this element here, which belongs to the user requirements, or this electrical requirement, which are actually rejected. So we can quickly search for elements in the database, as simple as that. Each one of the elements might have custom attributes like the status that updates the information here, priority, or any custom attributes that we might assign to him. So the fact that we are dealing with this with requirements from an information-oriented approach doesn't mean that we cannot deal with elements from a specification point of view. So this is the word-like view that we provide to help users actually write requirements. So many users feel comfortable writing requirements in a document-oriented approach. So why not create them in here? So if we have at the left-hand side the navigation panel, we can just quickly go to the corresponding element. We can check the description, make any modification, and we can also check the properties of each one of the elements. So for instance, this element, or the elements inside Visur have a set of properties that go from a discussion forum for each one of them, where we will be able to post all of our comments. But also we will have a history tab where we will be able to see all the modifications made to this element. So instead of having a document where changes are hardly traceable unless we keep track of them, in here we know exactly who made what, when, and we can compare them to find out what was changed. So in this case, the requirement changed the cost from 0 to 1,500, changed the status from ready for review to approved, and we can also see the description change. We can check it, that it's in red, and if we go down, it will have changed some. We can also highlight those changes by clicking here, and we will see that this element changed from 153 to 154. So it's a small change in the characters, but it might be a huge change from a system point of view. Perfect. So let's take a look at what we call the data model. So this data model is a graphical representation of the different element types. So let's go to the requirements process. Yes. In here we see the different element types, like the user requirements, system requirements, component requirements, and the corresponding test case. So this diagram indicates that we have a set of user requirements, and actually the specification we were taking a look a couple of seconds ago is located within this. Here we have system requirements, and we have component requirements here. The relationships in here indicate that user requirements should actually be traced to system requirements. The system requirements to component requirements and system. We can guarantee through this diagram that the elements will be traced in this way, and the traceability will be kept consistent. So users will not be able to trace user requirements to component requirements, for instance, or user requirements to components. So this is one of the diagrams. We can, for instance, navigate through the elements. We already saw the user requirement spec, but we can also navigate through the relationships. So I can select this relationship between component requirements and component tasks. I can activate it, and what I will be doing is displaying a trace matrix where we will have one of the elements contained in the first block in the rows, and the elements contained in the other one in the column. So here we're saying that calibration screen page, which is a component requirement, actually a software requirement, is traced to this test case in here. It might have several test cases associated to it. So we can use this not only to establish traceability, but we can also use it to do something like that. So right now I've selected to show the elements that are not traced to any component test. So here we've got these two requirements, these two component requirements that do not have any test associated to them. So we might have hundreds or thousands of component requirements, but what we're interested in is exactly finding out that making this coverage analysis. Perfect. So we have seen this V life cycle, and let's take a look at the system requirements. So system requirements are let's say the intermediate point between the business and the IT, in the sense that they can be seen from different points of view. They can be seen from a department point of view, like hardware, software, and mechanical, or they can be seen from a components point of view. So we can represent that duality in as many diagrams as we need. In here, we can represent things like the software development process, an issue tracking process, risk analysis, test results. But let's focus right now in the system requirements. So I'll open this diagram. And what we see here is that system requirements are divided or are classified by this generalization relationship into engine, interior, controls, and chassis requirements. So system requirements can be seen or can be allocated to these 4 different types of elements. At the same time, what we see here at the right-hand side is that system requirements can actually be software, hardware, or electrical. So perhaps the software guys just want to see all of the requirements, and the same for the hardware and the electrical. But at some point, the system engineer would like to see all of the requirements that have to do with the chassis. So here we can represent those 2 different points of view simply by giving a different name to the relationship. So here we have allocate, and here we have type. This is completely customizable. We could have called it whatever we want. Perfect. So how can we deal with these 2 different types? So let's go to a view where we can see this duality. And what we would expect is having the first classification in here, engine, interior, control, and chassis. And for each one of them, we can have this software, hardware, and electrical classification. Imagine we go back to the diagram and we add a new classification called, for instance, hydraulic. And we indicate that it's a type of system requirement. Let's make it a bit more interesting. Let's go back to the system requirements view, and let's see what we have in here. So as you can see here, we've got hydraulic for each one of the subsystems: engine, interior, control, and chassis. Why? Well, because the elements will have to be classified by these 2 aspects: the decomposition point of view, but also the type of. So this representation, as you can see, is created in the specification as a subchapter 1.1, 1.1.1, and so forth. So if we want to create requirements, we just simply create them as in Word. Actually, the engineers don't need to know how this document was created. Another very interesting aspect of this document, of this information-centric approach, is the fact that we can actually concentrate on any part of the document. So we can simply select from here whether we just want to focus on the engine requirement. And this is all that we will see, engine. Perhaps we want to take the chassis, so that's what we will do. So let's go back to the system requirement, and I'll create a new software requirement within the engine. So we just simply put here system failure recovery. So I've created this new requirement here within the software requirements of the engine. And what we see in this column are the tags that the requirement has inherited for the sake of being created at this point. So it's an engine requirement. It's of course a requirement, software and system requirement. So what if this requirement applies to hardware? So I can simply double click here and select hardware, and therefore it'll be automatically included in this section also. So the element, and you can check the unique identifier in here, has the exact same code or ID. It's because it's the same element. So if I change the priority, medium, the priority is changed everywhere. If I change the name, redundancy, the name is changed in both places. I can also assign it to, also assign other tags by drag and dropping. So if I drag this element here beneath electrical, the element will automatically be included in the electrical section. But not only that, but if I select this element and include it inside interior, the interesting thing is that the element is not only included in the software, but also in the hardware, which was the other tag I assigned it at the beginning. So interior, software, and hardware. So here we have the flexibility to create the elements whenever we want. So let's create a new hardware requirement. Hardware smoke test requirement for the interior. Okay, so this requirement only applies to the hardware within the interior. And let's check all the hardware requirements that our system has to comply with. I'll create a new hardware requirement in here. New requirement for the So I can select hardware, and what I'll see is the list of hardware requirements throughout every single component and subcomponent in our project. So here we have this engine and interior hardware requirement, this interior, and this control hardware requirement in here. Another way of visualizing this, and I'll go back to the full view in here, is displaying the elements from a completely different point of view. And just display this view where what we're visualizing here is the opposite way of displaying the elements. At this point, we mentioned that we wanted to visualize the hardware requirements, but not only the list of hardware requirements, but actually we want to see all the hardware that applies to the different components. So let's activate the hardware, and what we see is the hardware that has to do with the engine, with the interior, with the control, and with the chassis. So as you can see, as you can think about now, sorry for the disconnection. Somehow I got kicked out of my own presentation. So sorry for this interruption. And I'll take the opportunity to remember you that you can put your questions in the questions panel. We will leave some time for the Q&A at the end of the presentation. So what I was mentioning is that by now you will have figured out that for the fact of dealing with requirements from an information-oriented approach, we are capable of moving our requirements, organizing, classifying them, and visualizing from a completely different points of view, different views that might be different for different users, for different roles or different needs or activities. Perfect. So another very important aspect that we're taking a look at is the traceability. So if I select this engine requirement here and go to the properties panel and the related requirements panel, what I'll see is that I can actually trace it to user requirements, and I'll select some of the user requirements here, and I can trace it to component requirements based on the traceability policy I defined at the beginning in the block diagram. So once I've done all this traceability, what I would like to do is take advantage of it and represent a change impact analysis view. So I can go to this type of view, and what I'll see here is something like this. So I have this business requirement or this user requirement, which I trace to my system failure recovery redundancy requirement. I'll just make this so that it makes sense again. For security, and I trace it to all these component requirements. So if we are changing any of the elements, we can see straight away in this view all the affected elements by a change. So we can not only see it from this point of view, but we can also display the traceability upwards. So upstream, in here we have all the software requirements. So if there's a change bottom up, we can expand the element and see where it comes from. So for instance, a software requirement may come from a standard, a regulation, or anything like that. Perfect. So couple more aspects I would like to demonstrate is the quality analysis, which is one of the things we mentioned at the beginning of the presentation. So we have created some requirements, and we would like to know what's the quality of them. So what we have is what we call the quality analyzer. This quality analyzer reads requirement descriptions and indicates whether elements have high quality, medium, or low quality. So the assessment here indicates that this element has medium quality, this one has low quality, and let's actually double click on it and find what are the problems in it. So what we have is a natural language processing that will look for low quality aspects like ambiguity, like conditional terms, escape clause sentences, and so forth. So here we have expand this. Here we have all the problems we have found automatically in this requirement. So ambiguous sentences. We have 3 ambiguous sentences here. It is normally necessary to provide at least based on. So those are terms we should definitely try to avoid. We have speculative sentences, 3 of them. It is normally. We definitely don't want to have a requirement saying normally. May, it can, let's check some other aspects. Conditional mode should, in some environments, the should and the may have to be avoided completely. Escape clauses, like for example, generic terms, the user. So this is very interesting. This is very interesting because words like system, use, user does not add any meaning to the system because all the systems have to be used. So the term use is like saying nothing at all. So we have to try to be a little bit more precise in our terms. Exactly the same as system. Everything is a system, but are we referring to the overall system, to part of it? What is it that we're talking about? In here, we've also identified that this element does not have any incoming link. Zero incoming links. Is it because it's the highest level requirement? Is it because it has to be isolated? What is it about? Negative sentences. No, not. We have to be very careful, especially nowadays that we have international. So for instance, in English, a double negative is positive, but in other languages like French, like Spanish, a double negative means an extra negative. So many users are actually confusing the negative sentences. So we have to be very careful of that. Also, terms, we can check the terms in the glossary of terms to make sure that whatever we are talking about has relationship with our glossary. So if we have too many terms of the glossary in our requirement, we should actually consider dividing it into several requirements. Or if we are not referring to any of the terms in the glossary, then what might happen is that our requirement might be out of the scope. So we have to be very careful with what we do with it. So not only can we check the quality of individual requirements. As you can see, we have approximately 35 metrics, but we can also check the quality of the specification. So all the requirements in a specification might be perfectly written, but as a spec, it might have a very low quality. So what we have in here is this overlapping capability, overlapping view. So what we have to do in here is select two specs, for instance, component requirements against component requirements. And here we have the list of elements that are similar. So I'll actually pull the slide down. And what we see is that some of the elements are very similar. What does this bring to the table? Well, the first thing is that we can find elements that are meaning exactly the same. So if we're saying the same thing in two different places, why? The only thing that can bring is confusion, and we might actually accept one and reject the other one, and then we will have inconsistencies. But also, if we have two suppliers building the same thing, then we definitely would, most probably we're paying twice for the same thing. So, it's the case that some standards and regulations, we need to comply with a lot of things, and many of them talk about the same thing. So if two regulations talk about the same thing, then we should only be solving it once. But we first have to identify them. But that's what we can do in here. But also, we can not only detect overlapping, but we can also detect contradicting terms, because contradicting terms are typically very similar. And the only thing is that one of them might have a not. So let's just shipping size and shipping distribution. So this element here says that the SEU shipping crate shall be sufficient for its expected shipping and distribution environment. And here we say that the size of the shipping crate for the SEU shall be no larger than 130, 120, 180. So the first thing we see here is that, if we are already identifying the size of the SEU shipping crate, why do we have to have this requirement in here? I mean, if it's within the same specification, does it make sense? It might make sense in a previous page, but not in this page. So we can, for instance, deprecate this requirement, delete it, or something like that. It can only add confusion here. We also have the weight of the package SEU shipping crate shall be no more than 400 kilos. So exactly the same as this one. I mean, does it make sense to have all this redundancy here? If we scroll upwards, we have this one. The calibration screen shall display a red primary section with the light. The user choose the level of hue between 0 and 120. Whereas this one says that the calibration screen shall display green primary section with a slider that lets the user choose the level of hue between 0 and 110. So both might be absolutely correct. And one talks about red and the other one talks about green. But we already see that the range in here is from 0 to 120 and in here from 0 to 110. So is this correct? Is it not correct? Well, we should be just at least take a look at it and be careful with it. So hopefully I've been able to give you a quick overview on the benefits of an information-centric approach and how we can be more efficient dealing with requirements, providing different points of view to different users, having a control environment, but being able to modify it straight from the diagram, having a better adoption of the process changes. We created the hydraulic requirement in 2 seconds, and that was applied to different specifications to the engine and the rest of the system, and the reuse of requirements, which is a completely different topic, and we won't have time to take a look at today. So right now, if you have any questions, please put them in the panel at the right-hand side. I'll leave some minutes for the Q&A. So here we have a question about the database. What is it based on? It's an Oracle commercial database. So yes, all the information we have is based on a commercial database. It can be Oracle, it can be SQL Server, and then that database is centralized and the different clients access to that database. We have another question regarding the data models. Are the data models customizable? Yes, they are completely customizable. So we saw a couple of examples that we can basically configure and tailor them to our needs. We can create as many as we want and rename them and even change them as we see fit. Do you provide any templates for those diagrams? Yes. We have several templates that include not only those diagrams, but also workflows, access rights and permissions, attributes, and so forth. So we have a template for generic systems engineering, for avionics and defense, that's DO-178, DO-254. We have templates for IC 6204 and templates for ISO 26262. So if you're interested, please just get in contact with us, and we'll be able to provide them to you. We have another question on the pricing. What is what is the price of this tool? So we have two different licensing models. We have floating license, which is the most common one, concurrent licenses, and concurrent licenses. So I'll just tell you that it's pretty pretty affordable. We'll be providing you with pricing information offline with the different modules. We have Visur requirements. We also have the report manager. We haven't been able to take a look at today, but it's a separate component, and the quality analysis. So as I mentioned, we will be providing it offline. We have some time for some more questions. Here we have a question on reusability. How does reusability work? Okay, so let me just open very quickly the administration center. I'll try to be very quick with this one. So the administration center is the module in charge of the administration capabilities. So creating projects, creating users, and creating reusable components. In here we have this standard requirement, component that includes a set of requirements. And what we're seeing here is that we have 3 different versions of this component. We would be able to reuse this set of standards in the first version or in the second version. So if I select the second one here, what I see is the list of available projects and the list of projects that are actually reusing this version. If I go to version 3, what I see is that surgical imaging project is not upgraded to the latest version of this component. So what I'll do is that I'll share this update, and now the surgical imaging project will receive an update. So let's go to the client, let's open it again, and let's see what we can see in here. Perfect. So if we scroll down, what we can see here is that some elements have a lock in front of them. I'll take the description so that we can visualize them a little bit better. So these elements that have a lock in front of them are elements that are being managed in other projects. So the first lock indicates who's modifying the element, whether we are modifying the element or it's another user modifying the element. And the yellow lock means that this element belongs to another project, and therefore, in this case, I cannot modify it. So I cannot change the name or the description unless we let the rest of the projects create a variant out of it. Out of this requirements that come from other projects, we see 2 of them that are in red, meaning that they are outdated. So we just shared an update, and therefore these 2 elements automatically became outdated. So let's take a look at why they are outdated. So we go to the component view. We click on the button to upgrade the component. And what we see is that actually one of the elements that was highlighted in red is deleted in the latest version.
So we will have to be very careful when dealing with them, tracing test cases, or doing anything with it. The other element is actually changed. And what we see is that we have another element which is new. So we just click on next, 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 finish. And this should have upgraded. I'll take the description out. Perfect. And what we see is that the elements were completely upgraded to the latest version. Perfect. Perfect. So we've reached the end of the presentation. I would like to thank you for your time. We will be uploading the recording of the presentation. If you have any question, please don't hesitate to contact us, and we will be glad to schedule either a demo specific to your needs or answer any question you might have. So thank you very much and have a great day. Goodbye.